Example 4.3, case B. Both ends are insulated. Find the temperature distribution in a rod of length pi. That means here x equal to 0, end of rod equal to pi, which is totally insulated, or rate of heat flow equal to 0. So Ux, del U del x at x equal to 0 equal to 0. Heat at x equal to pi, or del U del x at pi equal to 0. The initial temperature distribution Fx equal to x times 2 pi minus x. At t equal to 0, Fx equal to x times 2 pi minus x. The temperature distribution satisfy the heat equation del U del T equal to 4 del squared U del x squared. Now we want to find temperature at any point of x at any time, or in terms of U, x, t. So solution, first we let U in terms of xt equal to x of x times t of t. Okay, then we find del U del t. Find del U del t from here, we get x t prime. Then we find del squared U del x squared. We get x double prime times t. Okay, next we substitute into the above heat equation. Okay, substitute these two equations into the given heat equation. Okay, from here del U del T equal to x times t prime equal to 4. Del squared U del x squared equal to x double prime t. Substitute here. Okay, then divide t prime divide by 4t, x double prime divide by x equal to negative lambda square. Why we take this negative lambda square? Because we want the final answer in terms of Fourier sine or Fourier cosine. And then because of when lambda equal rho equal to negative lambda square, we can find U, x and t at value 0. Okay, for lambda equal to negative lambda square less than 0, we put here t prime over 4t equal to negative lambda square, equation 1. Equation 1 here, x double prime over x equal to lambda square equal to this equation. Okay, and then multiply x times negative lambda square and then bring to left side. Same we do for this equation. Multiply negative lambda square 4t and then bring to left side, we get t prime plus 4 lambda square. Okay, then we change to auxiliary equation. When we change to auxiliary equation, x double prime replaced by m squared lambda squared times this one equal to 1. So we get m equal to m squared equal to negative lambda squared. Square root negative lambda squared change to complex number lambda I plus minus lambda I. Okay, same for this one. Okay, same as this one. M equal to negative 4 lambda square. M, okay, t prime change to m 4 lambda squared here. So we get m equal to negative 4 lambda squared. So for equation x, we get x equal to, because this is in complex number, we get c1 cos lambda x plus c2 sin lambda x. For equation t, because we only get m equal to negative 4 lambda squared, so we use t equal to C3 exponent negative 4 lambda squared. Take from here. Okay, and then combine these two terms. X times t equal to C1 cos lambda x plus C2 sin lambda x times C3 exponent negative 4 lambda squared t. So u x t equal to this equation. Okay, next we use the given in boundary and initial condition to find the value of C1, C2 and C3. In condition 1, given del u del x, okay, this is from ux or from the given in the question, given the temperature insulated. So we use del u del x at x equal to 0 equal to 0. Okay, so del u del x is equal to x prime t. Okay, here given 0, so carry value of 0 at x equal to 0, substitute x by 0. Okay, and then we know that t of t is not equal to 0, otherwise we cannot get the solution in terms of t. So x prime will be equal to 0. Okay, then we know that x of x equal to C1 cos lambda x plus C2 sin lambda x. Now because we have x prime, so we need to differentiate this one. Differentiate x equal to x prime. C1 cos lambda x differentiate equal to negative C1 lambda sin lambda x plus differentiate C2 sin lambda x equal to C2 lambda cos lambda x, and then substitute x by 0. Substitute by 0, x prime 0. Substitute x by 0. Sin 0 equal to 0. Cos 0 equal to 1. So we get C2 lambda here equal to 0 from the given x prime 0 equal to 0. So this one equal to 0. Okay. Now C2 lambda equal to 0. So we get two value. Lambda equal to 0 or C2 equal to 0. So we need to consider these two value. For C2 equal to 0, x of x, C1 cos lambda x. Substitute C2 by 0 here. So we only get C1 cos lambda x. For t of t equal to C3 exponent negative 4 lambda squared. This one carry from the previous step. So combine these two answer, we get u of xt equal to C1 cos lambda x times C3 exponent negative 4 lambda squared t. Now we need to find C1 and C3. So we use the second condition, condition 2. Given in the question, the temperature is insulated. So del u del x at x equal to pi is equal to 0. So we substitute x by pi into x prime. X prime pi t of t equal to 0. We use the condition that t of t is not equal to 0, implies that x prime pi equal to 0. Okay, x we know from our solution, x of x equal to C1 cos lambda x. So we need to find here, from here, x prime. X prime equal to differentiate this one, lambda negative C1 sin lambda x, and then substitute x by lambda. So we get negative C1 lambda, we substitute x by pi. So we get negative C1 lambda sin lambda pi here. Okay, then we use the statement that C1 is not equal equal to 0. If C1 equal to 0, we cannot get the solution in term of x because C2 already equal to 0. So C1 cannot be 0 anymore. So implies that sine lambda pi equal to 0, or lambda equal to 0, or sine lambda pi equal to 0. So we get from here lambda pi equal to n pi because sine n pi always equal to 0. So compare n pi and lambda pi. So we get lambda equal to n, cancel out pi and pi, we get n equal to lambda for n equal to 1, 2, 3. Okay, later we will discuss this one, lambda equal to 0. So we carry with sine lambda pi equal to 0. So we get x of x, C1 cos n x here, then C3 exponent negative pi n squared t. Replace lambda by n here, replace lambda by n because we get lambda equal to n here. So un of xt equal to C4, okay, because C1 times C3 equal to C4 cos n x exponent negative pi n squared t. Okay, we combine x and t, and then we combine C1, C3 become C4. Okay, next we proceed with lambda squared equal to 0 because we have in condition 1 and condition 2 just now we get lambda equal to 0. That's why we need to consider this value. If lambda squared equal to 0, so x double prime x over x is equal to 0. Multiply this one, so we get x double prime equal to 0. Same equal to t prime over 4t, multiply 4t and 0, we get 0 t prime. So t prime equal to 0.